So now we look at this bad layer here, and we are going to look and see what do we do to finish this lab out finally. Please, you know, I know you've been drooling and going, so let's get this lab over with, answer these 3 questions down here. Okay, so we've gone through now, you've done all the calculating, you get your percent errors. We expect percent error to be somewhere between 5 and 20% typically. As a matter of fact, if you don't have that percent error, something's wrong. Like if you got, I got 1% error. Look at me, I got 2%. No, because that means you've done it. That's not exactly not right. I know that sounds weird, but there is drag. There is drag on that top friction piece, and that makes it difficult for that tape to move up and down sometimes, especially with more weight outside. So if you don't get error, then I suspect something's not right. You should get error. I'm suspecting you'll get the most error on that last one. As I mentioned in the last video, you've got a lot of drag by having these 2 masses. Okay, I'm repeating myself. I'm going on. So 1, 2, and 3, what do? It asks about the relationship. And what I mean by that is direct or indirect, or direct or inverse, let's put it that way. Direct or an inverse relationship. Direct relationship means if one thing goes up, the other goes up. That's direct. Inverse means if one thing goes up, the other goes down. So I want you to compare. Now you're gonna have to look and compare your table, calculation table, and your data table. So let's kind of go through this. I'll tell you what you're looking for. Well, I'm telling you what to compare. I'm not gonna give you the answers. You figure that out. What's the relationship between velocity of the whirling object, can you see this, and the centripetal force that is exerted on it? So what I want you to do here is look at the velocity and the centripetal force, okay, that's exerted on it. We're going to use the experimental centripetal force, not the actual. Use your experiment. So you're comparing these numbers. Just come up with a relationship. What happens when you have a faster velocity? What happens to the amount of force that's exerted? Does it go up? Does it go down? So if they both go up, direct. If they both, one goes up and one goes down, indirect. Question 2. What's the relationship between the radius of revolution and the velocity of the whirling object? So now you have to look between 2 tables, because the radius, remember, was in the data table. So look at your radius, like 0.75, and the velocity on the calculation table is 6.63. Look at those. Then go on to the next trial and look at what happens. Go to trial 3 and look what happens there. Are they both going up? Or is one going up, one going down, right? Direct versus indirect. Look at those 2 different tables and compare those values. Then for the third one, question, what's the relationship between the mass and the velocity of a whirling object? The whirling object is the stopper. So the mass of the stopper, not the hanging mass. No, not the hanging mass, not this. The mass of the stopper. So you're looking at the data table for number 3. And comparing it to, okay, and the velocity of the whirling object. So look at the mass and the velocity of the whirling object. So let's see what happens. Now here you have a particular mass and a velocity of the stopper. Well, you're going to have to check out trial 6 and 7 to get the answer to this one, because that's where you varied the mass down there at the bottom of that data table for trial 6 and 7. Look at those masses and compare the velocities. Okay, one goes up, does the other one go up? Or if one goes up, the other one go down. Check those out. So in each one of these questions, you are velocity, velocity, velocity. So you're checking the velocity column on all 3 questions, but comparing it differently. Question 1, compared to the centripetal force exerted on it. Question 2, radius. Question 3, the stopper mass. Okay? So answer those questions. I want the answers either to be direct or indirect. You could say inverse as well. That's fine. Direct or inverse. And that's what you do for those. Look at your data, answer those questions. So the questions are pretty quick. You just look at your data pretty quick, and there's not a lot going on there. Look at your data, see what your data says, and you're good to go. All the effort really comes in to doing all this calculation. And yeah, it's a labor-intensive lab. There's nothing wrong with that. Nothing wrong with some of these labs are quick, and some of them aren't. Lab partner, sorry, this one you got to do work, don't you? Never promised you a rose garden, now did we? All right. Hope we've had some fun today. I'm all sweaty. I have to go take a shower now because I was exerting myself physically. See you next time, lab partner.